Hello, class. Welcome back. Today is an asynchronous day, which is why I'm recording this video for you now. And as I mentioned the other day, as I mentioned yesterday, today we're going to be going through lesson 29 in order to sort of look at a few sort of fringe examples, as well as kind of give us a little bit of shortcuts or kind of disprove some sort of miscommunications that we might have about certain topics. In this, we're going to have two exploratory challenges, and we're going to kind of look at claims and see if they're true or if they're false. These claims, they might help us. Well, no matter what, they're going to help us, but they'll either be shortcuts or they'll basically be warning us, hey, don't try to take this shortcut. So for the first claim that we have in our exploratory challenge number 1, we have to find 10% of a number, all you need to do is move the decimal to the left once. Why would I move the decimal to the left once? This isn't really going to make any... That doesn't really make too much sense to me. There's nothing in talking about decimals when it comes to here. So do I think it's true or false? I think this is false. Why talk about decimals? That does not look good. Let's erase that K and make it better. So why even talk about decimals in the first place? There just doesn't seem to be a reason. So, well, let's kind of test it. I don't think it's true, but somebody's claiming it's true, so we might as well test it. If that's going to be true for B, because it's asking us to determine 10% of 300. If that were true, that means all I'd have to do is take this decimal point and move it here. So if that's true, I should get an answer of 30. Well, let's test it. Let's see if it's true. Well, 10% of 300, well, that's 10%. 10% is going to be 10 out of 100. And since it's of 300, that 300 needs to be my whole. Okay, so that goes in the denominator. Oh, that's super easy. To get from 100 to 300, I need to multiply it by 3. So 100 times 3 gives me that 300. Okay, well, 10. I'm going to need to do my 10 times 3. And 10 times 3 gives... Wait a minute. That gives me 30. Okay, it gives me 30, but that could just be a coincidence. It could... I'm not wrong yet. Could just be a coincidence. There's nothing saying that that's going to work for every single one of these. No way. Let's check for C. Well, if this claim is true, well, moving that decimal place over once is going to give me 8. So if this claim is true, I should get 8. Well, we'll see if it's really true. So I'm going to have 10 over 100, because that's still going to be my 10%. And that's going to be equal to something over 80. Now again, okay, so this one's going to be a little bit harder. There's not a number that immediately gets me from 100 to 80. So in order to do that, well, I'm going to have to reduce this fraction. Well, the easiest way to reduce 10 over 100, I can divide both sides by 10, both my top and my bottom by 10. And that'll give me 1/10. Oh, and perfect. If I take my 10 and I multiply it by 8, I'm going to get 80. So that means I'm going to have to multiply my 1 by 8. Well, anything times the number 1 is itself, so that means my answer is... Oh. Okay, my answer is 8. I'm not throwing in the towel yet. I haven't proven it yet. Sure, it seems like it. It seems like it's going to work out. But let's just test it a little bit further. You know what I'm going to do? Well, let's do its claim first, and then I'm going to do something a little bit different when it comes to D and E. Okay. So the claim, once again, I'm going to move my decimal point to the left. So I should get an answer of 6.4. I don't like that 4. Should get an answer of 6.4. And you see, here's where it comes together. This is using it. This actually has to deal with decimals now. Those other ones, I just got rid of a 0. This one actually has decimals. This one can't work. Won't. So what I'm going to use right now, as opposed to what I had been doing before with this method, I'm going to do what we had done before yesterday with some of the things that sort of Sam suggested to us, if we remember correctly. If we remember back, well, Sam was like, well, in order to get from 10% to 100%, I needed to multiply my 10% by 10 to get to 100 in order to get to my whole. So if I want to get to my whole of 64, I'm also going to have to multiply my part by 10. Wait a minute. Moving decimal places? Multiplying things by 10? Wait a minute, that's actually what I have to do when I'm multiplying things by 10. I move my decimal point. Wait a minute. So this makes perfect sense. How did I not see it earlier? 6.4 times 10 is going to give me 64. And that means that I took my whole and I moved my decimal place over once. Okay. So then that means for this one, if I move my decimal place over once, I'm going to get 0.5, or again, I like to write it as 0.5. I like that leading 0. It looks empty without it. So I like to have that. So that means, well, my 10% times 10 is going to be 100%. That's going to be the same. I don't need to rewrite that. So I need to find out, well, 5 divided by 10, basically. Because I need to find a number that when multiplied by 10 gives me my 5. So that's the same as, well, what's 5 divided by 10? Well, that's going to give me 1/2. And 1/2 is the same exact thing as 0.5. Okay. So it worked. It did work. The claim was right. It seems. Well, let's see. What if we were doing things in the opposite direction? Before, we were given our whole, and we had to find our part. Now we're given our part, and we have to find our whole. Okay. Well, if going from our whole to our part, I had to move my decimal to the left. Maybe this time I have to do the opposite, because I'm doing the opposite in general. So maybe I have to do the opposite here as well and move my decimal 1 to the right. So if it's 1 to the right, that means my answer will be 480. Well, let's kind of test it. I'm going to do one test like this, and then I'm going to do, for G, I'm going to do it like this. Well, I'm going to have 10 over 100. And that needs to be equal to, well, 48 over something. Well, obviously, I can't go directly from 10 to 48 without multiplying by decimals, and I don't want to do that. So first, I'm going to divide it by 5 so that I can get 2. And then my 2 times 24 will give me my 4d8. Well, that means I have to do that to my bottom 2. 100 divided by 5, well, that's going to give me my 20. And then if I do that 20 times 24 like I did to my top, I am going to get 480. Perfect. So it looks like it is moving the decimal place to the right when you're trying to find the whole. Okay. Okay. We might be onto something here. Let's see if the same holds true for this. Well, if I was to move the decimal to the right one here, I would get 60. I get 60. Well, let's test it. We're going to do it this way. Well, 10% times 10, I'll rewrite that down here so that we know that we're using it. 10% times 10, that's going to give me my 100%. That means I need to take my part here, which is 6, and I need to multiply it by 10 as well. Oh, and would you look at that? 6 times 10, that gives me 60. So it works. If I'm trying to find my part, I need to move to the right one decimal. And if I'm trying to find my part, I have to move it to the left. If I'm trying to find my whole, I have to move my decimal to the right one. I mean, that only works if it's 10%, but that's a big deal. Well, let's look at H. Well, but H doesn't give us a percent. H says that Gary read 34 books of a 340-page book. What percent did he read? Why is this in here? This has nothing to do with 10%. Wait a minute. 34. Or, better way to look at it, 340. If I were to take my decimal and move it over once, I would get 34. And well, we kind of just proved that moving the decimal point in your whole to the left one, that means 10%, so it must be 10%. Nika read 16 pages of his book, and that's 10% of the book. Well, that just means I need to take my 16, I need to multiply it by 10. Because 10% times 10 gives me 100%. So 16 pages times 10 will give me my whole book. 160 pages. So Jay is asking us, well, what conclusions are we going to make about the claim? The claim is true. Despite all odds, the claim is true. The claim is going to be true. And we proved it. We proved it up here using the method that we knew and loved. And we proved it here, which actually helped us find out why it made sense to move the decimal in the first place. We found it out using Sam's method that he told us about yesterday. We were able to prove that this one was true. Now, we have exploratory challenge number 2. We have our second exploratory challenge. This one says, if an item is already on sale and then another discount is taken off the price, that's going to be the same as taking the sum of those two discounts off of the original price. Do I think that that's going to be true or false? Of course that's going to be true. If I have two discounts, I should just put those discounts together. And it should get me the same discount because they're both off. They're both discounts. Why shouldn't they be included? Since they're both discounts, why wouldn't I just be able to put them together and take it off the original? Well, I think it's true. But just because I think it's true doesn't mean it is going to be true. We have to prove that it's going to be true. So let's go about proving it. If I want to go about proving it, well, first I'm going to look at Part B. Part B over here is that Sam purchased 3 games for $140 after a discount of 30%. It's asking us to find our original price. Well, our original price, that's going to be our whole. And our 140 is going to be our part. So we're trying to find our whole here. After a discount of 30%, that means that that's how much was off, and Sam paid 70%. So Sam paid 30%. Sam paid 70% because 30% was off. Okay. So that means I'm going to have to take my 70 out of 100. And I need to find something with a denominator. We don't know the denominator. We have a numerator of 140. We need to find that denominator. Good news, though. Getting from 70 to 140, that's super easy. That means all I need to do is multiply my 70 by 2 and my 100 by 2. 70 by 2 is going to give me that 140, and my 100 by 2 is going to give me 200. That means that the original price for these 3 games was $200. Our original price was $200. Okay. That doesn't really answer my claim, though. Like, why are we doing this? Oh, because of Part C that we're going to be moving on to. Now, if these games weren't 30% off, they would cost $200. If they were 30% off, it would cost $140. But what if, off of that $200, Sam decided I'm going to use this $20% off coupon, and I'm going to open a frequent shopper discount membership and save another 10%. Would it still have a total of $140 off? I mean, if our claim is to be believed, yes. And since I believe the claim, I'm going to say yeah. It's going to still be $140. Because my 20% and my 10% together, that makes 30% off, doesn't it? Well, if we really want to do this, we're going to have to prove it. So my 20% off coupon means that originally I'm going to be paying 80% of what I would normally be paying, which is going to be 80 over 100. And for 80 over 100, I need to find something that is going to be equal to, well, my original price was 200. So let me put my 200 down here, because that's my whole. And I need to find my numerator. Well, this is super easy. Just like what we did up here, if I multiply my 100 by 2, I'm going to get my 200. That means I'm going to have to take my 80 and multiply it by 2 as well. My 80 times 2 gives me 160. So with 20% off, I'm at 160. Okay. Obviously, that's not going to be 140 because 140 was 30% off. This is only 20% off. So we're not there yet. We still have another 10% to take off before we can get to that 140. So, to take off 10%, well, what I could do is I could do 90 over 100, but we kind of just learned a super quick rule for finding 10%. If I want 10% of my newly found $160, all I'm going to have to do is move my decimal over to the left one. So 10% of 160 is 16. Okay, so that means that the 10% off is going to save me $16. So that means I need to take away $16 from my 160 to get my new price. So 160 minus 16, that's going to give me $144. Wait, what? So when I used my 20% and then used 10% on it, I didn't get the same as if I took 30% off? No. When I took 30% off, I got $140. It cost $140. But if I use a 20% and then a 10%, then it costs me $144. So, well, now it's asking, do I agree with the claim? I guess I don't anymore. No. I don't agree with this claim. Now let's think. Well, why weren't they the same? The reason why it's not the same to take 30% off of the original and then take 20% off and then 10 off of the new one is because the 10% that I'm taking off here isn't off of the original anymore. It's off of my new price. So I took my 20% off, and then my 10% wasn't off of the original price. It was off of my new price. It was off of my new price. Which means, if it's asking me, well, why do I not agree? Well, the second discount, oh, that D is not a part of discount. That second discount isn't off the original. It's not off of the original. It's off of the new price that's already been discounted once. Now, it's asking us, well, create a new, brand new example to help support your claim. For time's sake, this video is already about 24 minutes long, and I don't want to keep you guys for too much longer. I want you to be able to get your work done without having to watch, as was put yesterday, an hour-long video. So I'm going to skip creating a new example because we can easily see from the example that we already did that it's not going to be the same. Even if we did a second example, we still wouldn't get the same price. With that, that's all that I'm going over today. All that's left in this lesson is your problem set, which is yours to work on. If anyone has any questions, of course, I'm always free to enter into the Teams meeting. Obviously, during our asynchronous days, I'm right there waiting for a message to come through that says, hey, can you join the Teams meeting? I have a question about question 2. Many of you have already come in, asked me plenty of questions, so I know that you know I'm here to help. as I've already mentioned as well, sort of tonight/tomorrow before class, I'm going to be making and setting up the review packet, the review sheet for the Unit 1 test. As we know, this is the last lesson of our first module, of our first unit. Meaning, next Tuesday, we are going to be taking a test on this unit. What we're going to be doing tomorrow is you guys are going to be on your own working on the review sheet that I give you guys. If you guys have any questions about that review sheet, guess what? Tomorrow, I will not be answering any questions about the review sheet. Because on Friday, we are going to be going over the review sheet together as a whole class. Meaning, if you get to question 6 on the review sheet tomorrow and you're like, I don't understand this, Mr. Heisey, I don't get it. Well, what you can do is you can save that question and you can ask that question to me on Friday. You could say, Mr. Heisey, I didn't understand question 6. Can we go over that in a lot of detail? So then I'll be like, perfect, of course. And we'll go over question 6 as a class. Because odds are, if you have a problem with question number 6, there's probably someone else in the class that also had a problem with question 6. Now, lastly, the test is, as I mentioned, on Tuesday. We are going to be going over the review sheet on Friday, which means you need to get the review sheet done on Thursday, because there's a pretty decent likelihood that we're not going to have all class. Well, we're going to have all class, but we're not going to be able to have enough time to go over every single question that's on the review sheet in a lot of detail. So I want to make sure that everybody has it done so that we can quickly blaze through all of the questions that nobody has problems with, so that we can focus in on the questions that people do have problems with. So make sure when I give you guys the review sheet tomorrow to get it done tomorrow. Again, if you have problems with some of the questions on that review sheet and you're like, I just don't understand this, Mr. Heisey, I can't do this. Well, then skip it and go on to the next question. Do everything that you can. Other than the questions that you are just literally don't know, I want every question to be done on that review sheet tomorrow. With that, that's going to be all from me today. I hope that you all have yourselves a wonderful day, and I will see you all on Friday when we go over that review sheet. Farewell.